My name is Roman Lewis, and this is my extra credit video. Today we'll be doing this circuit and solving these problems. Alright, the first thing you want to do is read the question and find what you are looking for. So our question says, this switch was open for a long time, then closed at t equals 0, and reopened at t equals 1. Here we are looking for the voltage and the current across this inductor right before 0, as well as the voltage and current across this inductor right after 0, as well as the current across this inductor at t equals 1, and the voltage across this resistor right after 1 second. Alright, so first thing you wanted to do is redraw this circuit at t is less than 0. Alright, so since t is less than 0, this switch is open, so we don't include this part of the circuit in our redrawing. And also, since it has been at the state for a long time, our inductor acts like a short. And so, since our current, the current across our inductor is constant, and the voltage is the rate of change of the current, our voltage right before 0 equals 0 volts. Alright, now to find IL, we'll be using a nodal analysis at this node, which is represented as VR. Alright, so here we have VR. So on this first branch, we are given a current IX going towards the node, so this will be a negative IX. On this branch, we have the voltage, and we have a resistor, so it will be the voltage over the resistor. Here, we are given a current as well, so since this current is going towards the node, we'll write a negative 2 IX. And then finally we have this last branch, and the current across this branch will be the voltage of the node minus the voltage on the branch over the resistance. So it'll be VR minus 120 volts over 20 ohms. And this all equals 0. And we also have that IX equals negative IL because they are on the same branch, and but they are going in different directions, as well as negative IX equal to this node voltage over the resistance on this branch. So this is VR over 50. Alright, so plugging these equations in, we get that IX equals negative 1.89 amps. And since IL's negative, IX is just positive 1.89 amps. And we have that VR is 94.7 volts. Alright, so here, this gives us the answer for IL right before 0. So this equals 1.89 amps.
Not just circuits.
But since this is across an inductor and the current can't change instantaneously, this is also the answer for IL right after 0. Alright, now you want to redraw the circuit at t is greater than 0 but less than 1, because at this point our switch is closed. Alright, and we're looking for the voltage across the inductor, and this is different because the voltage across the inductor can change instantaneously. And since it's parallel to this voltage source, the voltage across our inductor is equal to this voltage source. However, since the polarities are opposite, our voltage right after 0 across our inductor equals negative 0.6 volts. Alright, and now to find the current across our inductor, we'll have to create an equation, IoT, for the inductor with our given current and our given inductance and our given initial current. So this would be
I don't know.
T naught on the integral of T naught to T of V dt minus
Not only you
I
have two
L,
weeks, you have 2 weeks,
which is our initial current. So this is equal to 1 over 0.2, which is our inductance. Our initial time is 0. Our voltage is negative 0.6, and our initial current is 1.89. All right, now to simplify this, we have, since it's just a constant value, we have negative 0.6 over 0.2 T plus 1.89.
That's a funny number.
And this is equal to negative 3T plus 1.89.
That's about right.
And this is
That's
our
how many assignments you gotta do in there.
inductor inductor current equation for
Let me see me.
the
Let me see me.
time
I
T
wanna
is
see
greater
me.
than 0 but less than 1. Alright.
That's how many assignments I
Now
have.
since we are looking for the current across our inductor at 1 second, we'll just plug 1 second in. And this will be negative 3 times 1 plus 1.89. And this is negative 1.11 amps.
Should be on the way home.
Alright, now the final thing we're looking for is the voltage across this resistor right after 1 second. So we'll have to redraw our circuit right after 1 second, and it will just revert back to what we had here. So T right after 1 second is Alright, now to find VR at 1 second, right after 1 second, we'll have to do nodal analysis. So it'll be very similar to the nodal analysis we did here, which would be negative Ix plus VR over 30 minus negative 2Ix plus VR minus 120 over our resistance, and this is equal to 0. And also we have that Ix is equal to negative IL. And since we are looking for the voltage of our resistance at 1 second, we have our IL at 1 second because we found it here. So this value is negative. So Ix is that. And we also have that Ix equals
Ammonium sulfide.
VR over 50.
So it's going
Alright, now plugging these equations into my calculator, we get that VR at right after 1 second, because our inductor current is right after 1 second as well, equals 58.68. So we have our VR at right after 1 second as well as our current and our current across our inductor right before 1 second, as well as right after 1 second. And we have our current across our inductor at 1 second. And we have our voltage across our inductor right after 1 second. And we have our voltage across our inductor right before 1 second.